Hey everyone, and welcome. Today we are diving deep into one of the most talked about, most hyped technologies on the entire planet, large language models. You know them, they're the brains behind all the chatbots and AI tools that feel like they're changing everything. But what are they, really? And are they actually as smart as they seem? Let's get into it.
We're going to kick things off with, well, a bit of a bombshell. This is a quote from Jan LeCun, who is literally one of the godfathers of AI, and he says he's not interested in LLMs anymore. Wait, what? Why would one of the world's leading experts just kind of dismiss the tech that has everyone else completely freaking out? To figure that out, we've got to understand what these things actually are.
All right, so let's peel back the layers here. What exactly is a large language model? Okay, so at its very core, an LLM is a type of deep learning algorithm that has been trained on a truly mind-boggling amount of text and data. This lets it just soak up all the patterns, the grammar, the facts, and kind of the vibe of human language. You can think of it like a kid learning to talk, but instead of just hearing their family, they get to listen to a huge chunk of the entire internet. They're not being sat down for a formal grammar lesson, and that's exactly what unsupervised learning means. It learns from the raw data itself without a human needing to label every single thing. Now, language models themselves aren't brand new, but what we're seeing today, well, it's not just a step forward, it's a massive quantum leap in what they can do. This slide right here really puts it all into perspective. Just look at the difference when you compare LLMs to what came before. The training data doesn't just go from large to bigger, it goes to very large. Performance jumps from high all the way up to the highest, and the hardware needed to run these things, yeah, it skyrockets to very high. It's this explosive growth in pure scale that has unlocked all these incredible new abilities. So, what does all that power actually get you? Well, a lot. These models can read 1,000 customer reviews and tell you the overall sentiment. They can take a 50-page report and generate a perfect one-page summary. And here's the wild part. They can even appear to reason, connecting the dots and figuring out answers that aren't spelled out anywhere in the text. So, how on earth does it all work? Let's pop the hood and take a look at the engine that makes all of this possible, and we'll use a model called T5 as our guide. This is where you see just how brilliant modern LLMs are. The T5 model is built on this super simple yet powerful idea. What if you treat every single language task, translating, summarizing, answering a question, checking grammar, as the exact same kind of problem? A text-to-text problem. You just give it an input text, like an English sentence, and it generates an output text, like that same sentence in French. This unified approach is an absolute game changer. But how can one single engine do all of that? The answer is this revolutionary architecture called the transformer. The easiest way to think about it is that it has two main parts. You've got the encoder on the left, which acts like an expert reader. It just pores over your input text, analyzing it from every angle to build this really rich, deep mathematical understanding of what it means. Then, it hands that understanding over to the decoder on the right, which acts like an expert writer. The decoder takes that complex meaning and uses it to generate the brand new text you asked for. It's this incredible system of deep comprehension followed by creative generation. Now, that transformer engine is seriously powerful. But the real secret ingredient, the thing that changed everything, is the large in large language model. And when we say large, we are talking about a scale that is honestly hard to even wrap your head around. 175 billion. That's how many parameters are in the famous GPT-3 model. So what's a parameter? You can think of it like a tiny microscopic dial that the model can tune and adjust while it's training. Each dial helps it weigh the relationships between different words and concepts, and it has 175 billion of them to learn with. And you know that massive 175 billion parameter model? It isn't some crazy outlier. It's just the biggest one in a whole family of models. As you can see, they scale up dramatically from a version that's considered small at 125 million parameters all the way up to that behemoth at the top. This direct connection, more parameters equals more power, is really the core reason for this AI explosion we're living through. Okay, so they're massive, they're incredibly powerful, and they're built on this really clever architecture. So let's circle back. Why would an expert like Jan LeCun be looking past them? It's time to bring this back down to reality. And here's the thing. For all their power, these models have some really serious limitations. They need an insane amount of data to learn. Their decision-making is basically a black box. We don't fully understand why they give one answer over another. And they have a really hard time performing well in languages that weren't a huge part of their training data. Fundamentally, there are limits baked into their very design. In other words, they aren't actually thinking.
And now that quote from the beginning makes a whole lot of sense, doesn't it? When Jan LeCun calls them just token generators, he's hitting on their most fundamental limitation. A token is basically a word or a piece of a word. The model is, at its heart, just a hyper-advanced prediction machine. It's constantly calculating the most statistically likely token to come next in a sentence. It's pattern matching on an unbelievable scale, but it doesn't have genuine understanding or memory or a real ability to reason about the world. Which leaves us with this final, fascinating question. We have built these incredible tools that can manipulate language with a skill that feels almost human. They are powerful pattern matchers that can mimic understanding, but it's still a mimic. The next great frontier, the thing that pioneers are already working on, is building an AI that doesn't just predict the next word, but one that actually knows what it's saying. So what do you think comes next?